Okay, in this video we're going to talk about some exponential function basics. This will be very similar to some other topics we've covered. We're going to be looking at tables and graphs and being able to interpret those tables and graphs, and also equations, and be able to apply those to problem situations. That's our goal with what we're going to be talking about. So let's get started on that. The basic exponential equation will be in the form of y equals a times b to the x. Okay, so our independent variable x will always be the exponent, and our dependent variable will be in its normal location by itself. So remember our rhyme real quick. Let's just review. For our independent and dependent, we always have this rhyme: xi dy. This means that our x is our independent variable here. So our x is always our independent variable, and our dependent variable is our y right there. So xi dy, xi dy. Okay, I think you guys remember that. We've talked about that a lot. So we still have our independent variable x right here as the exponent, and our dependent variable y by itself. Alright, so let's take a look at this a and b value. So let's start with an example equation here. So let's say we had y equals 5 times 2 to the x. So now we have our a value is 5 and our b value is 2. Alright. So the first thing we always do, our first step, always, when we are given an equation like this, we are going to go and put it in our calculator in y equals. So you can see I'm in the y equals screen here. We're simply going to put this equation in. 5 times 2 to the x. And you should be following along with me while I'm doing this. 5 times 2 to the x. The next thing we always do is set up our table. So in this case, we'll go second window, which is our table set. We want to start at 0 and go up one at a time. So remember, our table start is where our table will begin, and our change in table, remember the triangle in mathematics is the symbol for change, so our change in our table will be one at a time. So the next step, always, we've got 3 steps. This is the third one. We'll go second graph, which takes us to our table. So first step, y equals. Second step, set up our table. Third step, go to our table. Okay, so let's develop our table here. So we see that we have a table of values here. We've got x and we've got y. Alright, let's pull our calculator back up so you can see that we've got 0, 5, 110, 220, 340. So let's put that in. 0, 5, 110, 340. Should say 220 next. 220, 340, 480. That'll be good enough for now. Okay, so let's talk about how this a and b value are generated. Alright, so the first step is to look right here in the table. So I'm going to circle this for us. This is a very critical point, very important. This 0 and 5. Your a value, if you'll look at our equation here, you'll see this 5 right here. This 5 right there is in our equation right here. That's where it comes from. The first spot you will want to look in your table, if you've got the table, is when x is 0. Because when x is 0, that is going to give you your a value in the y column. That is where you can pick this a value up from. It's right here. When x is 0, y is 5 in this case, and the 5 appears as the a value. That will always be the case. So, again, if you have your table, x and y, like this, we can relabel this as 0a. It'll always be this case with an exponential function. That is where you will find your a value, right here. Whatever the y is equal to when x is 0, that is going to be your a value. Okay? So next we need to find this b value. So I'll show you how we do that. Let's back up a little bit here and clear this stuff out. Okay. The way that we find our b value is just like this. We are going to take this number, so for example the second number in the series, 10, and divide it by that number, the one just before it. So in this case it's 10 divided by 5. 10 divided by 5 equals 2. Alright, and even if we went down here to 20 and divided it by the number before it, we're going to get the same thing. So we're going to get here 20 divided by 10 still equals 2. We go down here to 40, divide it by the one before it, 40 divided by 20 still equals 2. 80 divided by the one before it would be 80 divided by 40, still 2. Notice this 2 value is our b value right here. So two things that we can do to get both the a and the b value. We look right here. When x is 0, what is y equal to? Whatever y is equal to is our a value right here. Our b value comes from, this is called successive ratios. It's a big term, but all it means is take one number and divide it by the one before it. Take one number, divide it by one before it. Take one number, divide it by one before it. Regardless, this pattern will continue and continue and continue. You take one value, divide it by the one before it, and you're going to get your b value. In this case, it's 2. And it's really that simple. From a table, that's all we have to do. So let's look at a graph now and how all this matches up. And we've already discussed many times that your table and your graph will always be the same. If they're not, then we've got a problem. So in this case, we're going to draw our x-axis here, our y-axis here, as always. We're not going to put a full coordinate plane in because we're not concerned with any negative values or x or y at this point. So now we can just start plotting our points. So I'll plot these in red. Okay, so we have the point 0, 5, so we'll put that, say, right here. Then we have the point 110, so I'm going to put that right here. Then we have the point 220, so I really need to label our axis here, so I'm going to put 10, 20, 30, 40 here on our y-axis. Down here I'm going to put 1, 2, 3, and that's all we're going to have room for at this point based on the way I scaled this graph. So we'll just graph these first few points here, first 3 points. So we have 110, then we have 2 and 20, it's right here. Then we have 3 and 40 up here. And actually I want to go ahead and extend this a little bit, so I'm going to erase that. Let's get our y-axis up a little higher so it'll make more sense. So we'll just extend that up. We'll put in 50, 60, 70, and 80. Okay, so let's put in 4 down here, and then that way we can add in this last point. So then we have 4 and 80 right up here underneath our equation. So if we put a smooth curve in to make that all fit, let's do that in another color. We'll pick orange here, that works. We're going to have this shape like this. Notice the shape of this exponential growth. This is exponential growth in this case. The increase is smaller and then bigger and then bigger and then even bigger. It really starts to take off. That is the behavior of an exponential growth graph. So let's look at our critical points now in both the table and in the graph. Okay, so remember our first critical point that we were looking for is our a value, and we found that at 0. When x is 0, what is y equal to? And in this case, it was 5. So our a value is 5. So if we look on our graph, you can probably imagine that that point is going to be right here, right on the y-axis. So in this case, when x was 0, y was 5. So this is where, right here, where we can pick out our a value from the graph. So our a value will always be right where we're touching the y-axis, right where we cross the y-axis, because that is when x right here is equal to 0. Okay? Now, the next thing that we can do is take our b value. So it's going to be the same thing. For example, we can take any 2 points that we want off of our graph. We've graphed 1, 2, 3, 4, 5 points here. So we can pick any 2. So we always pick 1 point. So let's take this one right here, which was the point 3, 40. Okay? And then we take the one before it. We always go back to the one before it. In this case, it was 2, 20. We take those y values. So we're going to take this one right here and this one right here. We take we take one value, which is 40, and the one before it, which is 20, and divide those by each other. So that's 40 divided by 20. Still gives us 2, just like it did over here in the table. So whether you're given a graph or a table, you can always develop your exponential function now. If you're given the equation, then you can build a graph and you can build a table. So we will practice several examples like this in class, but these are the basics. Okay? The only added difference that we will look at, we've been looking at exponential growth in this case. So quickly I'm going to cover the difference between exponential growth and exponential decay. Okay, with exponential growth, change colors here. So when we have exponential growth, it's this simple. It's very simple. Our b value must be greater than 1. If our b value is greater than 1, we have exponential growth. If we have exponential decay, our b value must be between 0 and 1. So we're going to put 0 here, 1 here, less than 1, greater than 0. So when the b value is between 0 and 1, so for example, if we had our b value was a half or a third or a fourth, anything like that, when it's between 0 and 1, it's going to be a fraction. In this case, our decimal would be 0.5 if we had a half. It would be 0.3 repeating if we had a decimal to be equal to 1/3. 1/4 would be 0.25, for example. So regardless of the way it's written, we could have y equals, for example, if we use this up here, we had 5, and we could have times 1/2 to the x. That's going to be decay because our b value right here is between 0 and 1. It could also be written this way. This is equivalent. 5 times 0.5 to the x. Same thing. Our b value right there is between 0 and 1. So it's decay. Our example up here was growth because our b value was bigger than 1. Okay? So those are the exponential function basics. Hope this video helps, and we will be practicing this in class, and this video will certainly help you be successful on those lessons and understand exponential functions.